Welcome to the next video in the series of videos on electromagnetism. In this video, we're going to look into both AC and DC generators. Before we look at the model, let's see the whole idea of an AC and DC generator. So what you have is you have two magnets. You have one magnet here and another magnet here. And here you have a set of coils. And here's an output that comes out from the coil. And here you have, this is a kind of a generator, so you have some turbine or something rotating this center. So usually in a hydro turbine, where hydro generating stations, you have turbines which rotate this whole center piece, and as it rotates, there is this coil here experiences a changing magnetic flux. So the magnetic flux keeps changing as this rotation happens, and due to that, you will find there is a we get electric current which is produced in this coil. And to complete this diagram, we have the setup where we have something called slip rings. So this is a first slip ring, and this is connected to this wire, and then you have the second slip ring connected to the output to the second wire. So this is the way you can see this model now and relate to it. So we have these two magnets, and here is something that we rotate with, and these two are called the slip rings, and these two are called the brushes, which take the current out, and then we have it in the galvanometer. So let's see what happens when I rotate this whole unit. So you can see that there is a voltage that's fluctuating in both sides, right? And the reason why that happens is because there is a changing magnetic flux. So as I rotate this coil, you see that the magnetic flux is maximum here, and it reduces as I turn here, and as I turn here it again increases, and as I turn here it reduces. Here it's zero because there's no line that passes through this area, because this area is horizontal to this magnetic field, and as I increase it, it changes. So as I keep rotating it, you will see that these fluctuations happen, right? Now to complete this diagram, you have the two brushes, so we draw these two brushes, and over there we get the AC that's the AC output. So that's how you draw this. Now the difference between AC and DC is quite simple. Instead of these two as two different slip rings, we have a single split slip rings. And that is shown, you can see this in this model. So in this model you see that. So this is one half of the slip ring, and this is the other half of the slip ring. So this part is the same. This part is the same, wherein you rotate it. Only the output you have, instead of drawing it from two different slip ring, you draw it from a split slip ring, which is split into two halves, which you can't see here, but it's essentially that split is somewhere here. So you see that two copper Ds are here on both sides, and center is insulated. So as you can see here, if I rotate this and try to see what the galvanometer shows, you can see that you will see that the deflection is only on one direction, which is on the left side. Which is on the left side. So you see that. But essentially the current changes, but changes on only one side. So to draw your DC generator would be exactly same as your AC generator. All you need to do is you need to draw this, and the first part is exactly the same. This is your handle, probably this is really bad drawing. Sorry about that. So this is a magnetic field which is N and south. And what you have here is you have a split slip ring. And that makes sure that always one end will be positive and the other end will be negative. So you can tap this by two brushes. So an output of this device would be something like this. Though it's not going to be steady, true DC would be something like this, but here it's going to be like this. So you saw that it was oscillating like this, right? Let's do a theory on how to find the EMF for AC and DC generators. I must caution you that this is for your higher classes, maybe in 12th, K12 or K11, and definitely not for your 10th standard. So you can watch if you're interested. So here is how we have the for DC, and if it is for AC, you have these split rings, like this. One you tap from here, and the other you tap. Sorry about this. Yeah, you tap one end like that, and this is not there. And let's assume that this is rotating at an angular velocity omega. So the angle that it makes, theta, will be at any time would be omega t, and the flux that this area A it links with this magnetic field would be given by phi equal to B dot A, and that is BA cos theta, which is BA cos omega t. Now the EMF from Faraday's law is given by minus N d phi by dt. That is equal to, where N is the number of coils, so that's minus N d by dt of BA cos omega t, and that's equal to minus NBA omega sine omega t, and this becomes plus because d by dt of cos is sine, and that is E0 sine omega t, which is E0 is given by this whole quantity. So that's how you get the output of AC as a sine wave, which means that what it says is your output is going to be like this, something like this. So I hope you enjoyed this video as much as I enjoyed making this. See you in the next one. Bye.